what's a pretty unique lesson for us. There's not really anything new that we're doing in this lesson. It's mostly review, but what we're going to do is we're going to learn different strategies for graphing based on the form that the equation's written in. We've been exposed to slope-intercept form and point-slope form throughout this unit, and we've talked a little bit about standard form. I've actually taken one line and written out its equation in all three forms on the right side of this slide to help you realize that you could see the same equation written in several different ways, and you need to know how to graph it regardless of which way it's presented. What we're going to do for the rest of this video is look at some examples and decide what strategies you might want to use to graph each of the different equations. All right, number one is definitely the most important problem that we need to know how to do. The first thing we're going to do is we're going to decide what form is this in. This looks to be in slope-intercept form. That's why I called this problem the most important, because you need to be able to graph from slope-intercept form. I can tell that my slope is -2 and my y-intercept is 4. So I will start at 4 on the y-axis. And remember, a slope of -2 means -2/1, so down 2 and right 1. So I'll go down 2 from 4 and right 1 to find my second point. And then I'll keep doing that until I fill out the graph. And now I'll simply connect the dots, and my line is finished. For number 2, I'm going to show you two different ways to do this problem. Option 1 is doing slope-intercept, but this equation's written in ax plus by equals c standard form. So to use option 1, what you need to do is manipulate the equation into slope-intercept form. I can do that by adding 2x and dividing by 4. And now I'm going to get y equals 1/2 x minus 1. So my slope is 1/2, or up 1, right 2, and my y-intercept is -1. So I'll start at -1, and I'll go up 1 and right 2, and continue to do that until I run out of room, and then I'll go backwards, down 1 and left 2. Once I have all those points on the graph, I'll connect the dots, and I have my line. Now I'm going to move that work out of the way and talk about a second option for this problem called the intercepts method. When you're in standard form like this, there's a method that says if you let y equals 0, which makes this term disappear, and solve for x, you'll get the x-intercept. And if you let x equals 0, which makes this term disappear, you can solve for y and get the y-intercept. This is because for an x-intercept, y always equals 0, and for a y-intercept, x always equals 0. So I want to show you how this method will also get you the same graph. So on the left, I'm going to let x equal 0, which is going to give me 4y equals -4, and I'll divide by 4 and get y equals -1. This is the y-intercept, which if we plot it on the graph, would be right here. Now on the right side, we'll let y equal 0, which gives us -2x equals -4, which if we solve by dividing by -2, gives us x equals 2. This is the x-intercept. And if we were to plot that on the graph, it'd be right here. Notice how those 2 points are on top of the line that we made with the first method? It's because they're producing the same graph. Now with those 2 points, I know that the slope is up 1/2, and I can continue to make more points on the graph, which will continue to overlap with the first graph we made. And again, connecting the dots would give us the exact same line we got with the first method. You do not need to do both of these methods. You don't necessarily even need to know both of these methods. You need to pick the one that you think is easiest and use that whenever you see standard form. Now, we move on to number 3, which is once again in standard form. So we have the same 2 options as to how to do the problem. We can put it into slope-intercept form, or we could find the intercepts. Let's do intercepts first this time. On the left, I'm going to let x equal 0, which means I have -4y equals 12. And by dividing both sides by -4, I get y equals -3, and that's the y-intercept. And now on the right, I'm going to let y equals 0, which should produce the x-intercept. This gives me 3x equals 12, since y is out of the problem. And if I divide both sides by 3, I get x equals 4. That's the x-intercept, which means where the graph crosses the x-axis. So I'll put a 4 on the x-axis and plot a point at -3 on the y-axis, and this should give me 2 points on my graph. We can tell that the slope would be up 3 and right 4, so I could go down 3 and left 4 to find another point, and then just connect the dots. to produce the graph. Now, just to quickly show you the other method, if I were to solve for y, I could use slope-intercept form. So I have y equals 3/4 x minus 3, which would tell me my y-intercept is at -3, which is the same as what we found with the other method, and I should go up 3 and right 4, which would put me right on that other point that we found using the other method. So for standard form, as we've shown now a couple of times, either method works. You can convert the equation to slope-intercept form and solve that way, or you can find the x and y intercepts and use those to generate the points. Now, number 4 is in a different form. This is in point slope form. So our point x1 comma y1 is at -3. Remember, when you see plus, it's actually minus with point slope, comma 5. And our slope is at 2, or 2/1, meaning going up 2, right 1. So if I plot this point on the graph, -3 comma 5, and then go up 2 right 1 and down 2 left 1 until I fill out the graph, I've produced the line. Now, in my opinion, this is definitely the easiest way to do point slope. However, some kids like to also do this problem using slope-intercept form. And converting into slope-intercept form is always an option. It's just sometimes you don't get a nice y-intercept. And if you notice for this problem, the y-intercept is not on the graph. That doesn't mean it doesn't exist. If we were to extend this line, we would just need the y-axis to be further up. So our grid isn't really big enough here to use that slope-intercept form, which would make everything a little bit more confusing if you tried to do it that way. Now, for number 5, this isn't in standard form or slope-intercept form, and in that case, my recommendation would be to just move things around to get it into slope-intercept form. So I subtract 2x and get y equals -2x plus 6, meaning that my slope is -2, or -2/1, meaning down 2, right 1, and my y-intercept is 6. So I'll start at 6 and go down 2, right 1 until I run out of space. And there's our graph. And I'm going to skip ahead to 7 and 8, where neither equation is in a typical form of a line. That's because these are either vertical or horizontal lines. Remember from our previous lesson, x equals a number is a vertical line, starting at x equals -3. So I'm just going to plot a vertical line through that point at -3. Remember, y equals is a horizontal line. So I'm going to go to y equals 4 and plot a horizontal line. Those problems are the easiest ones to graph. While there wasn't a whole lot new in this lesson, it served as a really good summary for all the graphing we've learned this unit. A couple of key takeaways for you. 1, know how to graph from slope-intercept form. This is the most important because you can always do it, and it's the most common form of a line that you're going to see. The other piece of advice I would give you is to be aware of these other methods because sometimes they can be quicker and easier ways to do the problem than having to get it into slope-intercept form in order to use that method. If you came away with anything else, write it down now. Otherwise, we'll see you next time.